Okay, on this video we are going to focus on finding unknown side lengths using the Pythagorean theorem. As a review, a squared plus b squared equals c squared is the Pythagorean theorem, and we drew triangles with squares on them like this. Okay, the two little squares add together to equal the bigger square. So here is a triangle, and we want to find the value of c. And so we are going to use the Pythagorean theorem and start substituting values in. So a squared is going to be 3 squared, b squared will be 4 squared, and c squared is going to remain. And then we simplify this fraction down, and we get 25 equals c squared. So the square root of c is, or the square root of c squared will be c. So we take the square root of both, and we get 5 as our answer. Sometimes your missing side will not be your hypotenuse. It may look something like this. So, notice the hypotenuse is 5. It's the longest side of the right triangle. So when we plug it into our formula, it's going to be substituted in for c. If you set this up incorrectly, you will get the wrong answer. So this is a huge common mistake that is made. 4 squared is 16 and 5 squared is 25. Then we just solve for a by subtracting 16 on both sides and getting a squared equals 9. To get a, we need to take the square root of both sides, and we get a equals 3. Here's another one. This time our missing side length is b. So when we substitute into the Pythagorean theorem, we're going to leave the b variable alone, and we're going to substitute our hypotenuse of 5 in for c. So 3 squared equals 9, the b squared stays, and 5 squared equals 25. So we end up with b equals 4. This works really nicely when you are working with a Pythagorean triple because they are perfect squares, so they are easier to deal with. Let's see if we have something a little different. Maybe we have a 2 and a 5 and a c. So we substitute this into the formula, and 2 squared is 4, and 5 squared is 25. So that is 29 equals c squared. Square root of that, we get the square root of 9. 29, sorry. So our answer is the square root of 29. You do not have to simplify it or change it in any way. Let's look at another one. Here we have 1b and the square root of 2. So we substitute these numbers into the Pythagorean theorem, and we take the square root of 2 and we're going to square it. So the square root of 2 squared is just 2. Then we start solving for b, and we get the square root of 1 is 1. So that side is a side length of 1 unit. Okay, so you need to be able to look at different word problems. For instance, maybe we have a building, and let's see here, some grass, okay, and we're going to try to get up to the top of the building using this ladder. You need to be able to see a right triangle in pretty much any given situation. Let me get a good highlighting color here. So you need to be able to see this right triangle here, so that whenever the problem tells you that this is, I don't know, 10 feet, and that this is 15 feet, you will be able to find the length of the ladder, which the ladder is just your hypotenuse in this case. So you would say a squared plus b squared equals c squared. A squared is 10 squared plus 15 squared equals c squared. 10 squared is 100 plus 15 squared is 225 equals c squared. This is when that perfect list or perfect squares list comes in handy. So we have 325 equals c squared. Take square root of both of those. This is not a perfect square, so we end up with c equals the square root of 325 whatever units. So we're dealing with feet here. You can, at this point, leave your answer as that, or you can simplify or approximate it down. But you need to be able to find right triangles in real-world situations and apply the Pythagorean theorem. It's very important for next week.